Probability, example 36C. A certain prescription drug causes dizziness in 20% of all of its patients who use it. Among a random sample of 10 patients, find the probability that at least 2 of them experience dizziness when taking this drug. So is this a binomial probability problem? Well, you can either be dizzy or you're not. And whether or not one person is dizzy has nothing to do with whether or not the next person in the trial would be dizzy. So it looks like it is independent, and so the probabilities would be the same. All right, so they're saying at least 2 of them experience dizziness when taking this drug, so our minimum is going to be 2. And our maximum, so we have 10 patients, so that's 10. So if I go with the direct approach, I'm looking for the probability of 2, or the probability of 3, or the probability of 4, 5, 6, 7, 8, 9, plus the probability of 10. So that would be a lot of probabilities to add. Why don't we look at the not approach? So we're looking at 1 minus, now what's missing? Probability of 0. And what else is missing? Probability of 1. Okay, so I'm going to choose the not approach. So I have 1 minus, we had 10 trials. I'm going to look for 0 successes there. So success here was causes dizziness, so that's 20%, so 0.2 raised to the 0 power. So 0.2 would be success, 0.8 is going to be failure. 100% minus 20% is 80%, and that is the decimals 0.80, or I can just write 0.8. So the number of failures in this case would be 10 minus, and then the probability of 1 success. So I have 10 trials, 1 success, 2/10 raised to the 0 power. Oh, nope, that's a lie. To the first power. And 8/10 to the 9th power. Can't take it, I need to erase that there. Okay, so we put this in our calculator and we end up with 624 thousandths.